Hello everyone. Welcome back to our channel. In our quest to bring the latest in space technology, today we will talk about a spacecraft. A spacecraft smaller than your thumbnail, racing through the cosmos at 1/3 the speed of light, headed straight for a black hole. Sounds like something ripped from a sci-fi movie, right? Well, hold on to your telescopes, because a real astrophysicist, Cosimo Bambi from Fudan University in China, thinks this might be possible not in some distant future, but potentially within our lifetimes. Sort of. There's a catch. The mission could take about 100 years from start to finish. The mission idea is elegant in its simplicity. You start with a nanocraft, basically a tiny spacecraft weighing just a few grams. Picture a microchip attached to an ultra-thin reflective light sail, maybe the size of a human hand. Then, from Earth, you point a ridiculously powerful laser at it and blast photons toward that sail. Those photons push the sail forward, kind of like wind filling a boat sail, except the wind here is light. And because photons travel at light speed, the sail can, in theory, get moving really fast. Up to about 1/3 the speed of light. That's more than 100,000 kilometers per second. For context, that's roughly 10,000 times faster than a commercial airplane. At that kind of speed, this nanocraft could travel to a black hole about 20 to 25 light years away in just 70 years. Now, before you say 70 years, that's a lifetime. Remember, space travel is painfully slow. If we tried to do this with a regular rocket, it would take tens of thousands of years. Once it reaches the black hole, the probe would start collecting data, snapping images, measuring gravitational effects, and maybe even testing the very limits of Einstein's theory of relativity. Then it would send all that precious data back to Earth, which would take another 20 to 30 years to arrive. So from the day we launch to the day we get our answers, you're looking at roughly a century. If you were a kid when it launched, your great-grandkids might be the ones who actually see the results. Okay, here's the tricky part. First, we don't actually know where the nearest black hole is. Black holes are basically invisible unless they're feeding on nearby matter, so spotting one quietly floating in space is tough. Cosimo Bambi believes that within the next 10 years, new telescopes and detection techniques will help us find a black hole in that sweet spot. Close enough for the trip, but far enough that it's safe for the probe to approach. Second, we don't have the tech yet. The lasers required would need to be absolutely enormous and insanely powerful. Building such a system today could cost around €1 trillion. That's more than the GDP of many countries. But here's the hopeful bit. Bambi thinks that within 20 to 30 years, advances in technology could make this way more affordable. Just like how your smartphone today has more computing power than NASA's computers from the Apollo era, future engineering could shrink costs dramatically. Why spend a century chasing a black hole with a probe the size of a postage stamp? Because black holes are the ultimate testing ground for physics. We know Einstein's theory of general relativity works beautifully, but we've never truly tested it in the most extreme conditions. If we could send a probe right up to the edge, the event horizon, we could answer some mind-bending questions. Do black holes really have a sharp boundary where nothing escapes? What actually happens to matter and light as they get close? Could there be unknown physics happening at that point? It's the kind of experiment that could either confirm our understanding of the universe or completely rewrite the textbooks. And here's what's fascinating. This wouldn't be a see-it-in-your-lifetime kind of mission. This is generational science. Think about it. The people who launched this craft might not be alive when the data comes back. But they'd be part of something bigger, a relay race of discovery, where the baton is passed through decades until one day humanity gets the answer. It's a bit like planting a tree you'll never sit under. It's not just for you, it's for the future. So here's my question for you. Would you support a space mission you'll never personally see completed? One that's built not for us but for people 100 years from now? Let me know in the comments, and hey, if you enjoyed this cosmic deep dive, hit that subscribe button so we can keep exploring the universe together.